We have here a homogeneous differential equation. As usual, I want you to pause the video, write it down, and make an attempt at solving it. Okay, have you finished doing that? Now, let's look at the solution. And remember, while I go through the solution, if you had started and got stuck, wherever you got stuck, when you see me pass that point, the next step, just pause the video and you take over from there and complete the solution. Because remember, you don't learn maths properly from sitting down watching somebody do it. You learn by actually doing math. Alright? So, you must practice. So now, let's look at what's going on. We have y minus 3x is equal to, plus 4y plus 3x dy by dx is equal to 0. Let's see something here. Remember, with homogeneous differential equation, you cannot solve them by direct integration. You cannot solve this by separating the variables. So you're going to make y be equal to vx, where v and x, v is a function, alright? So that dy by dx, when you differentiate vx, you hold v as it is, times derivative of x with respect to x, plus you hold x as it is times derivative of v with respect to x. So what you have there is differentiation using the product rule. Alright? Now we have a dy by dx here, and there's a dy by dx here, but you want to transpose and make this one up top the subject, then we can equate the functions. Now let's add 3x to both sides and minus y from both sides. We have 4y plus 3x dy by dx equal, this would be add 3x to both sides, gives you 3x minus y. Alright. Let's divide by 4y plus 3x, which would cancel itself here. Divide by 4y plus 3x. Good. Now remember that y is equal to vx. So change these y's to vx. So 3x minus vx over 4y, that's 4vx plus 3x. Alright? Now, we could factor out the x over here. And we say x outside the bracket, inside the bracket we have 3 minus v over x outside the bracket, inside the bracket we have 4v plus 3 and cancel out. Alright. So here now, we have dy by dx being equal to v plus x dv by dx, so let's write that down. V plus x dv by dx, and that is equal to, and this is also dy by dx, 3 minus v over 4v plus 3. So it's 3 minus v over 4v plus 3. Alright. So we have two variables. There's x and v. Let's finish putting them together and separate the variables. Subtract this v from both sides. So we subtract it, v minus v, that's gone, that's 0. And all of this here, minus v. Alright. Let's do some fractions here and combine this into one. This is a fraction, 3 minus v over 4v plus 3, minus another fraction, which is v over 1. We could use common denominators, but I'm going to draw the line here, find the LCM of 4v plus 3 and 1. LCM is 4v plus 3. 4v plus 3 into 4v plus 3 goes 1 times. 1 times 3 minus v is 1. Minus 1 into 4v plus 3 goes 4v plus 3 times. 4v times v is going to be v. 4v plus 3 times v is going to be v times 4v plus 3. Okay. So what we have here? 1. Oh, why do I have 1 up here? It wouldn't be 1. 4v plus 3 into 4v plus 3 goes 1 time. 1 times 3 minus v is 3 minus v. My mistake, I wrote that one up there. It should be 3 minus v here. Alright, so this is 3 minus v minus v times 4v is going to be negative 4v squared. Negative v times 3 will be minus 3v all over 4v plus 3. Alright, so x dv by dx is equal to negative v minus 3v. That's negative 4v minus 4v squared plus 3. Alright, you have that over 4v plus 3. Okay, good. This is a quadratic equation in v up top. It is negative 4v squared minus 4v plus 3 over 4v plus 3. So what we have now is to multiply. If we multiply both sides by 4v plus 3, because we want function of v dv on the left equal function of x dx on the right. This will be 4v plus 3 divided by the negative 4v squared minus 4v plus 3. So that will be over negative 4v squared minus 4v plus 3 times x dv by dx. This would be 1, right? Because you divide by this and you multiply by this, so both of them would cancel. But now, let's divide by x, both sides by x, this over x, this over x, divide by x, so that x is gone, then multiply by dx, so dx. Okay, so what you have is 4v plus 3 over negative 4v squared minus 4v plus 3 dv equal 1 over x dx. Good, we separate the variables v and x. Now we want to integrate both sides. We could use partial fractions to deal with this. Let's see if this can be factorized first and then use partial fractions. You have the AC method. A is negative 4 times C is 3. Negative 4 by 3 is negative 12. We find two numbers are add to give AC. No, multiply to give AC and add to give B. B is negative 4. So two numbers. If we try, well, the 4 and the 3, they multiply to give negative 12. But they wouldn't add whether the 4 is negative and the 3 is positive, or the 3 is negative and the 4 is positive. They wouldn't add to give negative 4. Let's try 6 and 2. The 6 would have to be negative. Negative 6 plus 2 is negative 4. Negative 6 by 2 is negative 12. Okay, so these are the numbers, 6 and 2. So the integral, well, the integral of 4v plus 3 over. Now, we're factorizing the quadratic. At one end you have negative 4v squared. At the other end you have plus 3. In the middle we separate the negative 4v into negative 6v and plus 2v. Alright. And that is equal to the integral of 1 over x dx. Now, what happens after this? We have the integral of 4v plus 3 over what now? We factorize these two. We have negative 2v outside the bracket. Negative 2 into negative 4 is positive 2. Negative 2 into negative 3 is positive 3. But v, let's take out the v. It is 4v, 2v plus 3 here. Alright, we'll factorize these two. And then plus, so in this case, you factor out 1 and 2v plus 3 inside the bracket. And that is equal to 1 over x dx. So after this now, we are finding the integral of 4v plus 3 over, take out the 2v plus 3, 2v plus 3 in one bracket, I'll say 1 minus 2v in the other bracket. Alright, good. Now, that is dv. There's a dv here. Now, we want to use partial fractions here. So 4v plus 3 over 2v plus 3 times 1 minus 2v equal a over 2v plus 3 plus b over 1 minus 2v, right? If we multiply both sides by 2v plus 3 times 1 minus 2v, we would have 4v plus 3 equals a 1 minus 2v plus b 2v plus 3. Alright, let's get rid of the a. Let 1 minus 2v equals 0. That means that negative 2v would be negative 1 if we subtract 1 from both sides. So v would be half then. No. Yeah. V would have to be half, right? V is a half. So if V is a half, we'll have 4 times half plus 3 equals a times 1 minus 2 by half. You know that's going to be 0, but I still write it there, just as a reminder. Plus b 1 minus 2 times half. So what we would have now, 4 by half is 2. So 2 plus 3 is 5 equal 2 by half is 1. 1 minus 1 is 0. This is 0 plus 2 by a half is 2. Oh my. It's b 2v plus 3. I wrote the wrong thing here. When I'm substituting, should be b times 2v plus 3, but v is a half. 2 times half plus 3. 2 by half is 1. 1 and 3, 4. Is 4b. So b is equal to 5 over 4. When you do the transposition, b is 5/4. Alright? So make sure you get that part. Remember your integration by partial fractions. When you multiply, with 4v plus 3 equal a, and 1 minus 2v plus b times 2v plus 3, because they cancel when you multiply both sides by 2v plus 3, 1 minus 2v, right? So if you let this be equal to 0, and you find that v is a half. So we put half in here to find a. To find b, because we eliminate a. A would multiply by 0, because you make this 0. 4 times half plus 3. 4 by half is 2, 1, 3, 5. Alright? This would be 0. 2 by half is 1. 1 and 3, 4. So b is 5 over 4. We're going to do the transposition, right? After that now, alright, we can't scroll down anymore, so let us draw a line to separate the working on the screen, and then we continue from there, right? Okay, yeah. So as you see, this has quite a bit of work in it. If you get this in exam, it would have to have significant amount of marks because of the amount of work you have to do, right? Now, a significant number of marks, I would say. You have 4v. Let me just copy this, combine, and put it up here and work with it instead of having to try and remember. I just copy it and slide it up. Alright? So that I'm trying to remember what it says and be scrolling back and forth to see if I have the right thing. So here now, we found B already. Let's eliminate B and find A. Let 2v plus 3 equals 0. If 2v plus 3 equals 0, what would happen? Then 2v would be negative 3 and v would be negative 3 over 2. Alright, if v is negative 3 over 2, you'd have 4 times negative 3 over 2 plus 3 equals A. 1 minus 2 times negative 3 over 2 plus b. I know this is going to be 0 anyway. 2 times negative 3 over 2 plus 3. Alright, 2 into 2, 1, 2 into 4, 2. 2 by negative 3 is negative 6. Negative 6 plus 3 equals A times 1 minus, well, it's going to be plus, it's a minus, so it will end up as a plus. 2 cancels 2, so 1 plus 3. B is going to be cancel. Negative 3 plus 3 is 0, right? So B is eliminated there. So negative 6 plus 3 is negative 3 equals 3 and 1, 4. 4a. So A is equal to negative 3/4. Alright, so here we have A and we have B. Now let's look back at this. We have the integral of this. See, this is the same thing as A over 2v plus 3. Let me write it. A over 2v plus 3. So we have this is the integral of A over 2v plus 3 plus B over 1 minus 2v, right? B over 1 minus 2v, and that is equal to the integral of 1 over x dx, equal the integral of 1 over x dx. Now what was A again? A is negative 3/4. Let me just put the negative 3/4 here. And b, what was b again? 5/4, which is same as 5/4. So 5/4. All right, dv. So what you really have here, you can separate these. These will give you two separate integrals. You can have -3/4 integral of 1/2v plus 3 dv plus 5/4 integral of 1/1 minus 2v dv equals the integral of 1/x dx. See that? Now, you can use substitution, integration by substitution, to deal with these. If you have been doing a lot of integration by substitution, once you get enough practice, you can see exactly what will happen here. It's going to be ln this over -2. But anyway, just as a reminder, let us do it. If we should find the integral of 1/1 minus 2v dv, we can let u be equal to 1 minus 2v, then du by dv would be -2. So dv would be equal to du over -2. And then what we have is the integral of 1/u, which is 1 minus 2v. This is u, 1/u dv. But dv is du over -2. So this is the same as 1/2 times 1/u du. Right? That's what will happen if you do this. So you see, it's going to be -half ln u plus c, which is -half ln u. U is 1 minus 2v plus c, right? So here is going to be ln this over the derivative of this. Once you have been doing a lot of integration by substitution, you'll be able to see it quickly without having to go through the process that I did a while ago to be integrating them. So this now, this integral is -3/4 is going to be ln 2v plus 3. What do you think happened? Divided by the derivative of this. If you differentiate this, you get 2. So it's divided by 2. Alright? Plus, now 5/4 ln 1 minus 2v divided by the derivative of 1 minus 2v with respect to v, which is -2, which we saw a while ago, equal, and then we integrate this now, it's ln x, and we put a plus c. Remember, we don't need to put a plus c on both sides, right? Or a constant of integration on both sides. Alright, so what happened now? We have -3/8 ln 2v plus 3, because 4 2 is 8, right? Well, this will be minus 5/8, because it's 4 and then 2 under here would multiply, ln 1 minus 2v equal, well, c itself, you know, is a constant and we don't know what it is, but we can consider it as the ln of another constant. Call it ln d. But ln x plus ln d is the same as ln x times d, or dx. Alright? Remember your rules of logarithms, or your laws of logarithms. Now here, the laws of logarithm again. This would be ln 2v plus 3 to the power of negative 3, 8 minus ln, or plus ln 1 minus 2v to the power of negative 5, 8 equal ln dx. You see that? Because I've put it to the negative because this can be written as plus negative. So it's plus negative this. So I use it as a power. Now, again, laws of logarithm. This is ln 2v plus 3 to the negative 3, 8 times 1 minus 2v to the negative 5, 8 equal ln dx. Alright? So it's ln of all of this. See that? Now, if we have e to the what is on the left equal e to what is on the right. E to the ln number is equal to that number, whatever the number is. So what we have is 2, the number is 2v plus 3 to the negative 3, 8 times 1 minus 2v to the negative 5, 8 equal e to the ln dx. Just gives you dx. Alright? Now, how can we fix this up even further? Let's see now. If this is 1 over 2v plus 3 to the 3, 8 times 1 minus 2v to the 5, 8. Laws of indices. Remember, when you have a number raised to a negative power, it's the same as 1 over the number raised to the same power, but now it's positive, right? Equal dx. Alright. Now, what you can do, you know. Alright. The thing is, if you were in an exam, right, you could finish off at this point here if you have limited time, but let's still continue looking at this thing and see how we can fix it up even more. Suppose you say now, what could we do with this? Suppose you raise everything to the power of 8. Suppose you play around and do that. 1 to the power of 8 is just 1 over 2v plus 3 to the power of 3, 8. If you raise that to the power of 8, you get 3, because 3, 8 times 8. When you raise to a power, you multiply the powers. And this would be 1 minus 2v to the power of 5 equal d to the 8, x to the 8. Right? Now, suppose you multiply both sides by 2v plus 3 and 1 minus 2v. You would have 1 equal d to the 8. Well, d to the 8 is just another constant, so let's call it, say, e. Ex to the 8, 2v plus 3 cubed, 1 minus 2v to the 5th. Right? Get everything flat, and I'll put it like that. So, here now. Oh, by the way, v, remember that y was vx, so v would be what? V would be y over x. Alright. So, yeah, I I had said earlier that you would get full marks, but you would only get full marks if you had changed the v back to x and y. I didn't remember to change it back to x and y, right? So even if you had reached this point and then you change the v to x and y, that's how you would get full marks. But remember, you need to change the v back to x and y. So here now, you need to change the v to x and y. 1 equal e x to the 8. 1 equal e x to the 8. What happens after that? 2v plus 3 cube. We have 2v plus 3 cube. 1 minus 2v to the 5th. Alright. And we say that v is equal to y over x. Remember, y equal vx, so v is y over x. So let's change that now. Let's put all of this on the other side, on the left. So we have e x to the 8, 2 y over x plus 3 cube, 1 minus 2 y over x to the 5th equals 1. Well, guess what? This e, you can divide both sides by e too, you know, and call it something else because you don't know what e is. E is just a constant. So if you divide both sides by e, you get 1 over e. 1 over e, you don't know what it is, so let's call it f, constant f. So what would happen here? Oh, guess what? Look here. You could make these fractions, you know, and say the LCM is x. X into x goes 1 time. 1 by 2y is 2y. Plus 1 into x goes x times. X times 3 is 3x. So all of this to the power of 3. We could make this to the 3 over x to the 3. And this is multiplied by, put this over 1. Draw the line, find the LCM, fractions. LCM of 1 and x is x. 1 into x goes x times 1 is x. Minus x into x goes 1 time. 1 times 2y is 2y. So up here is 2y to the 5th over x to the 5th. And we have x to the 8th. Where I write e to the 8th. X to the 8th times all of this equals f. But guess what now? We could say now, how would it go? X to the 8th. Suppose we multiply everything by x to the 5th. X to the 5th. Right? This would be x to the 8th, x to the 5th. No, we wouldn't be able to multiply. Oh yeah, man. If we multiply by x to the 5th, this would be 2y plus 3x cubed over, let's put the x cubed here. We multiply this by x to the 5th. X cubed. And we have x minus 2y to the 5th. 5, 6, 7. Hold on. Let's not do that. Very interesting here. Very, very interesting. Let's rewrite this and make it x to the 8th. Now, these multiply now. So it's x to the 3 times x to the 5. So 5, 6, 7, 8. This x to the 8. Oh, the x is cancelling now. And 2y plus 3x cube, x minus 2y to the 5th equals f. The x is cancelled out here. Very interesting. So, what we have is x minus 2y to the 5th, 3x plus 2y cubed equals the constant of integration, right? All right, so that's it for now. But as I said, this question is a lot of work. If you had this to do in an exam, well, I could give this and say show that the solution is this as a take-home assignment. But if you had this to do in an exam, it would carry a significant amount of marks. And then, let me see now, if you say reach this point, right, and then you change v back to x and y, right, that shows that you know what you're doing. Full marks, right? The rest of what I did was just to kind of pretty it up, neat it up, right, put everything together, get rid of the fractions and so on, make everything flat, and the negative powers and so on. And this is really neat and nice. Looks a lot neater than this, or the one with the ln, right? But anyway, I'll see you in the next video.